All right, so we have second speaker, Jon McLachlan. So Jon is going to speak about a project he's been working on for a while that I don't know too many details about, but I'm excited to hear. So everyone give Jon a welcome applause.
Thanks, Nick. So we're going to do the old switcheroo with the display. All right, so this is going to be a very different type of talk. So I'm Jon McLachlan. I'm the founder and CEO of Peacemakr. This is really a passion project that kind of turned into a company. And it's still a passion project, and it's all bootstrapped. And so there's a huge list of names of very talented and dedicated engineers that I would love to put up on this slide. But everyone who's participating in this as an engineer is really sensitive to the whole, oh, I have a day job sort of thing. And they don't want to put their current employers in an awkward position. Given that, our agenda here really quickly is just to talk a little bit about what is application layer crypto. I'm not sure that this audience needs to go into depth in that one. Why is it important? What are the fundamental challenges that are common across the board when we try to introduce application layer cryptography into our apps or programs, our deliverables essentially, and how does Peacemakr address some of these challenges? And we'll end with a quick demo. So what is application layer crypto? You could think of it as anything outside of the TLS networking layer, anything that's actually inside your application itself. Specifically, what Peacemakr is addressing, though, is that data privacy component. Crypto is really just a tool, and the application layer crypto that we're going to be talking about is specifically geared towards crypto as a tool for data privacy and user privacy. And so why would a business need application layer crypto? There's lots of different reasons. Maybe you're trying to stay GDPR compliant. Maybe you're trying to get a HIPAA, HIPAA compliant. Perhaps you have a whole bunch of statically available content that you would like to encrypt and accelerate the access to those assets by using something like Cloudflare or edge compute. So you make those available on the edge, accelerated, statically encrypted. And when users use your system to access those assets, maybe you're streaming something from Netflix or you're renting something on iTunes, when they actually hit your active systems that are deployed up in the cloud, they're gaining access to the key and they're downloading the asset locally from some locally accelerated component. So when you think about application layer security, it's tough. Specifically because threat models are difficult to think through, and the more specific that they are, the better and easier it is to build a system that can address it. And when your threat model includes data privacy, you have to ask certain questions. You're private against who or what? And for how long does that data need to be private for? Oftentimes that's an aspect that is left by the wayside. And of course, if you can get away with recognition, you don't need crypto. You could just hash something or use an HMAC or whatnot, and you can have a recognition of the same piece of data showing up in your system over and over again, as opposed to retention, where you need an actual bijection. You need to go back to the original data that was provided in your system. And when you think about these systems, I'm sure everyone in this room has built and has participated in building various flavors of all of these different types of systems. And when you step back and you look at the bigger picture, I can't help but ask, are there some common pains? Are there some common denominators that we could all be using together, that we could actually share and solve some of those core problems, and not have to keep rebuilding the same types of systems over and over and over as we progress together. And so when you're building one of these types of systems that requires application layer crypto with the goal of data privacy, you have something that's going to be doing some crypto and it needs a key. It needs a key to perform your crypto operations, say a symmetric key. And the question is, where does the key come from? So there are solutions out there already. There's cloud KMS solutions. Google has one, Amazon has one, Oracle has one now. They're all viable options in terms of just a safe place to save your key. Some of them have interfaces where you send them a plaintext and they'll send you back the ciphertext. So you could build a system like this, but then perhaps that doesn't scale to meet your needs. And so maybe in-house you end up developing a little crypto service that the crypto service is now going off and connecting to your KMS solution that you've decided on, that meets your business needs in terms of what you're willing to spend. And you have all of your clients that will actually be performing the crypto. Maybe your crypto service is going to do the actual encryption on behalf of the clients. And so the clients will be sending plain text to a crypto service. The crypto service could be doing some encryption operation. Maybe it needs some state now because it's a stateful service. So there's a database of encrypted keys. And to decrypt to those keys and gain access to the whole system is talking to the KMS solution to get your quote unquote master keys. But then you look at this and you think about scale and you decide that there are so many clients that are going to be doing encryption and decryption operations that this won't fit the bill, that you'd have to scale your crypto service out. And why not push that operations down to the clients themselves? That makes a lot of sense, to have the things that actually need to do the encryption and the decryption actually perform those crypto operations. And so oftentimes your crypto service will turn into a secure key delivery service. And so now your clients will be fetching keys, and now you have to think about, okay, how do I securely move that key material from my crypto service down to a client, right? And depending on what type of client that is, there's going to be different questions that come up in terms of how you may be willing to do that. And if you're especially lucky, you'll have a business requirement come through where your crypto service will have to maybe integrate directly with a piece of hardware called an HSM. These are sold by Thales, and it used to be SafeNet, but now they were consumed by a larger organization, Thales. And they all speak PKCS11, which is supposed to be a standard. And it is a standard on paper, but when it comes to the actual implementation, everyone has their proprietary, PKCS11 library that speaks only to that one device. And now you're kind of locked in. You're locked into this ecosystem that's connected to an HSM. I'm just sort of curious, who here has worked with an HSM before? Direct? Yeah, okay, good amount. It's quite the experience. And so you've got to a point where you've built something that looks similar to this, and you've already invested a lot of time and resources into it, and you know what you're going to be encrypting and decrypting, and you're starting to give talks to the rest of the engineering org about, hey, here's what we're going to do. Here's the pieces that are encrypted and decrypted. If you need access to this information, please go through this system. Here's how you access that system. And you have a first-class system that's now like tightly coupled to the quality of your production uptime. Your crypto service that you have to keep online. You're signing up for a lot of responsibility when you build a system like this that's distributing key material across an ecosystem. So keep in mind that this investment in infrastructure and technology and the team, that commitment, it takes a lot of money, a lot of time and energy to get that right. And it's a commitment not just to build the thing, but to support it going forward through time. And then you stand back and you look at the bigger picture and you're like, okay, can we ship this? And you start asking some really good questions. How do I securely back up my database? What about key rotations? Because time is an important component to my data privacy, right? To hit that threat model, I have to think about the time component, not just the space component of how I'm segregating my risk. How how do I deploy, high availability groups over this HSM? I can't just have 2 or 3 that's stuffed in the corner, even though I know maybe sometimes that's how you ship, a proof of concept. Or how do I back up that HSM? And then you start thinking about the clients. You're like, oh, did I pick a good crypto library on the client? If I change my mind later, is that easy to pull out and put a new one in without breaking backwards compatibility? Can I incrementally roll out new updates to my client without breaking the backwards compatibility of everything that I've already shipped? These are all important questions, and the crypto that we decide to build and we bake into these clients, they're going to have lasting consequences on what you can do in the future. Not just what we can do in the future in terms of security engineers, but what your entire engineering org can do, depending on what's being encrypted and how it's being encrypted, and what's expected on the server side, if these things are talking to servers that also gain access to the keys. I think in our previous talk, there was a mention that we'd like to be able to move off that EC DSA crypto, the signing algorithm, but because of the legacy that's in place already, it's impossible to move. And so even with all of these questions in the air, you have a product manager come by, or maybe a VP of engineering, and starts asking you some tough questions on a Friday afternoon, like, oh, does it work? And you're like, well, yeah, but, and they're like, okay, great, we need to ship it. We need to meet this deadline. And you're like, and they're like, oh, it's just the MVP, don't worry about it. I know I've been in situations similar to this where, yes, the thing works, that it has some nice, I'd be comfortable exposing it, but it certainly wasn't up to the bar that I had hoped in terms of, shipping quality product. And if you take a step back and you think about the bigger picture, and you think about those common pains that we all share, when we think about application layer crypto, there's a lot of common denominators here. Essentially what we're building is we're building a secure key delivery system. And on top of that, what else do we need? We need a rotation system, right? To rotate your keys over time so that nothing is fixed and forever. And of course, the crypto that's underneath the hood here is not magic. Crypto doesn't magically solve problems. It makes systems more complicated inherently. It just makes systems more complicated. When you start using crypto, things get more complicated. Your engineering velocity slows down a little bit, but essentially what's happening is transforming problems, because we've all convinced ourselves that it is easier to protect those keys than it is to protect the client data. And that's a true statement, and I believe that statement, but sometimes we don't give the grit that is required of protecting those keys, that are full, all of the love that problem really deserves. Oftentimes it's not our faults, it's just the constraints of the situation, of the business needs. I'm sure that there's lots of apps out there that probably could have benefited from the privacy that crypto provides, but didn't pursue it because the bar to actually introduce application layer crypto is pretty high. So there's this notion of trust, and all of this trust goes back to those questions of, do we trust where we're getting those keys from? Do we trust that key delivery system? Do we trust that the keys are living, short enough lives? And do I trust the place where I'm backing up the keys? And this all has to do with the keys. The keys that, when we're using application layer crypto, all of this business always goes back to, do we trust the keys? And the mechanisms controlling and orchestrating the movement of keys and secrets in the system. And so this is where we get to Peacemakr. Peacemakr simplifies cryptography in the application layer for data privacy purposes by handling all of that dirty business underneath the hood of managing those keys. The key distribution, the key rotation, and by hiding the keys or handling the keys, what do I actually mean by that? Here's a quick example of the interface. It's ridiculously simple and dumbed down. You'll see that this SDK client can register itself to the cloud. You can perform sync operations, which just means, hey, it's a good time to go do some network operations. That's fine. And encrypt and decrypt. And you're passing your plaintext into the encrypt and your ciphertext into the decrypt, and there's no business about picking a key. There's no business about identifying a key or passing in a key or even an AAD or an IV, or worrying about where the entropy is coming from or where the key is derived or what algorithm or mode your symmetric crypto operation is going to show up in, or where did you get your asymmetric key pair for actually receiving a key from wherever it's going to be derived, you know, nebulously out there in the cloud. So the goal was to lower the bar, to make crypto more accessible, at least the application layer crypto much easier to use, to digest, to integrate into your app without fear of committing to something that, you know, is going to bring a lot of overhead to whatever your enterprise may be. And I could talk a lot about this stuff. I thought maybe it would be interesting to just do a quick demo. So, as I set this up, a good place to start would be the website. Let's see. So you can go to peacemakr.io. You can read much more in detail about the ideas that I'm talking about here. Anything that you would ever run on a client, on your own software, and you would integrate with is open source. So at the moment, we have SDKs that facilitate these super basic crypto operations in Java and Go. There are other SDKs in the works right now, including Python and Swift for mobile clients and Android. So you can check those out. But really what may be interesting is if you go into the Java, the README, okay, there's a quick start guide and then there's an example application. And this example application is just the bare bones, simplest operations that you may want to perform. It takes an API key, so you have to register and put in an API key so this piece of software underneath the hood can connect up to the cloud, register itself as a client, publish that public key that's associated with this particular client, and put itself in a position to start receiving those secret keys from your organization. The Get Crypto SDK is just the factory call to initiate the interface. And so once you have one of these objects instantiated, you can call encrypt and decrypt, and the hello world is just going to get encrypted. We're going to violate the abstraction layer a little bit and just print out what that looks like so you guys can see it. And then we're going to decrypt it again. Let's pull that up. Oh, that was anticlimactic. Okay, so if we just run, so the only modification I've made is to include our my little test API key here. You can do a git diff. So I put an API key into the standard open example code, ran it. You can see, okay, there's a lot of stuff happening here underneath the hood. And you can ask a lot of really interesting questions. What algorithm was used? Where does the key come from? Like, why does it look like there's patterns in that? These are actually, there's a lot of identifiers and markers that are describing just in the clear exactly what key was used. There's key IDs floating around. There's identifiers that we're actually encoding which algorithm was used. So anyone that picks this up down the road knows immediately what they need in order to be able to decrypt it. And there's a signature in here too. So for non-repudiation purposes, whoever is encrypting these messages is also signing these messages. You can configure that on your server. And we have this little portal, the admin portal. I'll blow this up. So that API key, for me, it just came from this little test organization that I have. In our live production environment. So if flip through here, you could see crypto configurations. So my environment at the moment is configuring all my clients to use RSA keys and 2048-bit encryptions and all of those keys are going to last at most 2 years on the clients. That seems like sane defaults. Admin users are just people that can log in and change these settings. There's this concept of a use domain. So a use domain is just a collection of keys that have expiration periods on them for both encryption use and decryption use. And it's going to instruct these clients that have all of the integration points exactly which algorithm to use. It's going to mention when the use domain was created. And underneath that use domains, that's where your symmetric keys are actually being held. There's this notion of a key deriver. And a key deriver is just the component in this system that is going to be deriving the keys and delivering them to clients. So it's wrapping individually derived keys with NIST 108-800 standard, I think it is, derived and then delivered to whoever needs keys. You can see a list of the registered clients that are currently registered to your org. They have a little client ID, the date that they showed up, and their public key that's associated with them. And really, that's it. I'm happy to take any questions that anyone might have.
Oh. Hello.
Can you swap out other encryption? I came late. I went to a bullshit Apple security thing that wasted my time and missed your great presentation. So I'm going to ask about that. And as an ex-Apple guy and Cisco guy, I really resent that. But I'll go back to what I was asking you. Can you swap out different key pairs or encryption schemes or encryption libraries? And what are the support that's been built in for it already, if you don't mind me asking?
So our guarantee to customers is that you don't have to worry about the backwards compatibility or the crypto library that's underneath the hood that's driving all of this. We'll keep all of those up to date. You can roll out incremental versions of your app and just not have to worry about, even if you change the, the crypto decisions that you would like to see in the cloud. The idea is to control all of the management in the cloud, have all of the crypto happen away from the cloud. As the key drivers, obviously, and the places where you're actually doing your crypto, those are private, trusted places. Not at the moment. Those are all very good questions, though.
Nice talk. One question is regarding the defining of the encryption keys on the client side, right? Right now, at the app level, sort of you have your API key, and based on that, you use the drive the key. But if one app wants to produce data encrypted, another app wants to consume that, how you handle the pinpointing, I want to use this key, and obviously as well authorization, is this app allowed to use that key for encryption?
Right. So the auth-z question is a great question in terms of who is allowed to gain access to what key. And once you establish basic rules about who's allowed to gain access to what key, you can do really interesting things such as that. At the moment, the future authorization scheme that we'll be building into this is going to be based on your API key, which really, I would really like to see that static token disappear and be replaced by a JWT. Or even an OpenID Connect scheme for auth-n. But then when you talk about auth-z, auth-z could really be connect back to this idea of a use domain. And so if you have specific application layer needs for, I need to segregate risk over here, one part of my app from another part of my app to another part of my app, you can do that through different use domains. And then enforce auth-z based on, which app in particular is authorized with a Z to gain access to specific use domains. So in short, use domains, different use domains can help segregate risk.
Thanks. If I may ask another question, do you support as well providing on-premise sort of like HSM integration such that if someone has more, like is more, want to have like different security requirements, they can have use their own on-prem or their own cloud providers HSM service?
So we do, so this is offered in two forms at the moment. The first form is just a basic SaaS where everything is happening up in the cloud. It's easy to get going. There is another form, which is an enterprise form, and we can custom tailor, you know, running this. This is just software. We can run software anywhere.
Thanks.
Yep.
Can you go back to the demo real quick? Just what you have shown on the screen for the demo. So if I had a database of, say, social security numbers or phone numbers or anything I wanted to protect under whatever GDPR or HIPAA, whatever I need to do it, is every single one of those pieces of data going to be inflated to about 30x size using this?
So you notice that we're not using compression at all.
No, I understand that fully, for sure.
And the reason this is so bloated, and the short answer is yes, it would be something similar to this.
Okay.
But one of the reasons that this is so bloated in particular is that I had configured that use domain that we were looking at for this test use domain to a RSA 2048-bit signature,
Right.
which was part of the non-repudiation piece of the.
So would that be applied per data element then? So like again, like let's say I had a low latency, high throughput application where I needed to do things with credit card numbers. Would each one of these things need to be as big as that to get these security properties that you talked about?
I mean, we could certainly run this through a compression algorithm that would shrink it a little bit, but it's going to be bigger. Yeah.
Okay, I mean, I just was curious, like, is it about that much bigger?
It's about that much bigger.
Okay. Thank you.
Right. And actually what's working in benefit for performance on this system is that all of the keys, once they're downloaded from the cloud, they're decrypted and they're used locally, they're cached in the runtime memory of that client. So there's a small initial overhead once you come online as one of these clients, but then everything is going to be very, much faster. Underneath the hood, the actual crypto implementations that we're connected to are just open SSL implementations compiled for whatever architecture that you're running. So pretty fast. Great questions.
You said you download the keys on the device and then you're doing all the encryption and decryption there locally. How are you persisting and storing those keys on the device?
Oh, that's a great question. So actually, on the interface, if you look very closely at what we offer in the open source space, there is a small persister helper that, we implement a couple of them where it could save it on a file if you'd like on a file. If you'd like a custom implementation of how, the SDK is going to ask the higher level application to persist things, you can implement those yourself with a different algorithm. Everything is open source and Apache 2.0 license. So, pull requests are more than welcome. All that stuff.
So I understand this is sort of a first cut. How do you imagine this API, that really simple API you have changing over time as you add all sorts of things that people are going to want, some of the auth-z that you're talking about, being able to know who am I encrypting this blob for, signatures, different privacy domains, different key rotation policies where sometimes I want old keys to be useful and sometimes I don't. How do you expect this to change over time?
Yeah, that's a really great question. I'm not sure what to expect, and I was hoping that the market could help guide that, which this is the very first exposure that this stuff is sort of getting. Where we're revealing, the guts of all of this and not even sure exactly what the future has in store. But I guess the short version of all of that is that we're open and excited to listen to hear what the needs are from the community.
I would be afraid of JWTs, just as you mentioned that. They've had problems in the past, and one of the issues, I'd have to think back to some of the specific security bugs, but back a few years ago when I was last dealing with this, having a very simple API that, for example, didn't distinguish public and private key, or sorry, symmetric and asymmetric keys, things like that, was a source of security holes in it. So, and I encourage looking at some of the history around that and making sure those mistakes don't get repeated. One other question, so just make sure I understand, this is a commercial company that is a SaaS that provides sort of encryption keys as a service?
Yeah.
Okay. Yeah, some measure to not have to trust the central thing. Using some key splitting technology might be good too.
Oh, don't get me wrong. We do not want to be in charge of other people's keys. But to write the software and to solve that common problem of getting sensitive data where they need to be and then actually employing use of the keys. Because if you use keys, if you get keys somewhere securely and then misuse them, it's still kind of a bucket of problems. And as I've built crypto systems over the years and have had great opportunities here to contribute to different projects, it's always the same problems over and over. And it feels like if we just had that central control with the crypto actually happening on a complex and distributed system, but still retain that central control, it solves a lot of really difficult problems. Just as you need to change over time, you need to add or remove crypto algorithms or key requirements to close that next big deal or whatnot, or even just integrate with a low budget app. I'm sure there's plenty of those too. Other questions? These are great questions too, by the way.
Here you go.
I think it's one of the fundamental computing problems. The question is, so that's why some of the people actually built this bullshit blockchain stuff with bad security. And yes, I said that on purpose to start a fight. So yeah, but I'm open to discussing it, what quantum and other things can do for real. But here's a question I have to ask. Aren't we trying to solve the problem at the same level of thinking of the problem? Because isn't the real problem we don't have real trust of the OS system that encrypts? That's the same problem with we don't know for sure what bytes are being written, what threads are happening. Is it thread safe? Do we have, though people use Dart, you got protected threads. We don't have an SSD compiler to squeeze all the performance out of there. We need microsecond, serious high frequency trading level performance on every client device with a hard drive SSD, and with the ability to make sure what happened. Because otherwise you're just pushing it to a device I don't trust. So is there a way or a thing you look at that maybe we could contribute to in the open source project that would help with that? What area would anybody think about how we could add that level of trust? Because we're going to have it. We're not going to trust the blockchain and also the crap with things like nuclear power systems and power systems on shit that we can't audit. NIST is going to bring that. So I'm wondering what's the piece we could add to this, because I like your approach actually.
Thank you. I appreciate that. No, you hit it on the button. The problem is trust. And the problem is the question on the table that we all think about as security professionals is what systems do I trust? And when I trust a system, what exactly does that mean? Do I trust it with everything? Do I trust it with the crypto? Do I trust the operating system? Do I trust the kernel space? Do I trust the hardware?
And that's actually a thing. It's a variable. It's not a full thing. If I could know what level of trust, I could arbitrage the ROI on that. That's what we don't know. That's why we're working on stuff like that with the overwhelm. We don't know 99% of the information on the internet on what public pages. And we definitely don't know 99.9% of what's happening on your hard drive or your memory on your phone. If we could start with that, we could actually get close to managing risk like we do with our guys over at the what's it called? The risk model guys who calculate with the Monte Carlo stuff. I forgot, they're out of San Jose State. I forgot what it's called. It's getting late for me. But yeah, that's the question. Do you have data and statistics about risk from your overall network? Because I know you guys get hit a lot. And you mainly stay up, which is
there's no data on that. This is brand new. This is
overall across systems, so you could say the risk level for a device like this in the past for your network. So therefore, if you could put that percentage there, that would take us 60% where we need to go.
Yeah, I think those questions about trust and to what extent do we trust systems can and should be driven by data, as you're suggesting. Yeah.
Yeah, I'd love to contribute or help with a project like that. I've got a lot of devices we access.
Oh, okay, awesome.
Thank you. All right, well, let's give John another round of applause. Thank you again. And so thanks to John and Emma for showing up. We're going to keep this place open for another 20 minutes or so. If you want to get a pizza, chat, talk with people, there's drinks available. And again, thank you for coming, and great to see everybody.